All right, guys, we're going to continue on with section 5.2. Good news today is most of the stuff we talk about here is stuff that we've covered in our geometry review at the start of this trimester. So I'm just going to do a few examples with inverse trig functions. We have not yet done those with radians, so I want to cover that too. I did steal the directions from the textbook. It says find each angle in the first quadrant, which means that we'll just be doing acute angles, which is nice. And then these first couple questions, we're doing those in degrees, and they are asking us to round to the nearest tenth of degree. So remember that when you see theta, that's a variable, that's an unknown, and we're trying to solve for that. So if we want to undo sine on both sides, you would have to take the inverse sine on both sides. Theta is equivalent to the inverse sine, or remember the arc sine means the same thing. And that should spit out a degree measure for you. If your calculator is in the right mode, you should be double checking that. And they asked us to round that to the nearest tenth of a degree, so we'll say 25.7 degrees. So you just want to practice that whether you're using your phone or TI-30. I actually think it's probably easier to switch the mode on the TI-30s, but it is what it is. Question 2, tangent again of the unknown. So to undo tangent, we would do the inverse tangent of both sides. Tangent and inverse tangent are inverse operations, so those cancel out. You're left with just theta on the left. And then on the right side, inverse tangent of 1.2456. Again, same instructions here, so we want that in degrees. When I did that, I got an extended decimal, 1.5, etc., and we're rounding to the nearest tenth of a degree, so 51.2 degrees. Okay, same instructions, but this time they want that angle measure in radians instead. So again, I'm going to solve for the unknown by taking the inverse cosine on both sides. And inverse cosine, cosine, those two cancel each other out or undo each other, as you like to say. And I'm typing that in with my calculator in radian mode. And when I do that, I got 0.96635. I'm not quite sure about the rounding. Let me pause real quick. I want to see what the textbook has to say about rounding for that. Okay, for the radian measures, they want 3 decimal places. You don't have to put the label on there, but not a bad idea as you're still getting used to radians. So that's in quadrant 1. Again, if you think about the unit circle, this is pi radians, so that means that's 3.14. So if you think about where 0.96 might appear, it's about 1 radian, which is over there in quadrant 1. So, okay, next we're going to get through some application questions. Find the missing side. Ooh, we've done this a lot. Look at the given information. Sometimes you have more than one option to choose. I'm given this angle measure. I know information about the adjacent leg, and I'm trying to find information about the hypotenuse. So that should tell you to use cosine. Cosine of 35 degrees is equal to adjacent over hypotenuse. And then to solve this, remember if you have a bridge, you may cross it, a little shortcut we can use. So B equals 26 over cosine of 35 degrees. And I got about 31.7. And that's a length, that's not a degree measure. Actually, I think the textbook has us round to nearest whole number. You'll just have to look at the instructions for each individual problem here. So let's see, that would be 32 feet, inches, whatever it may be. Here's our next application, an angle of elevation question. It says the top of a building. Surveyor, we're going to do some surveying, hopefully, if we get back to school here at the end of the trimester. Here's this little guy down here with his tripod surveying machine. He is 330 feet from the building. And the angle of elevation is 22 degrees. So he's got his little machine here. And the angle of elevation from that machine to the top of the building is 22 degrees. So what we've done is we've made a right triangle here. I know that the base of that triangle has a length of 300 feet, and I'm going to be interested in finding the height, which I'm going to call x. Identify the appropriate trig functions. As I've mentioned before, almost always in angles of elevation and depression, it's going to be tangent. And again, that is because I want information about opposite. I have information about adjacent. So tangent of 22 degrees is equal to x over 300. When I solve that, x equals 300 times the tangent of 22 degrees. And I'm going to plug that in my handy dandy calculator in the correct mode. And when I do that, I got 121.207 blah, blah, blah. Is that the answer? And the answer to that is no. That's because this transit is 5 feet off the ground, so that's going to add an additional 5 feet to the height there, so we can get the entire height of the building. So 126 feet if we're rounding to the nearest whole number. All right, my last example here, let's check it out. Express the exact value of each function as a single fraction. Do not use a calculator. And if you notice, we're going to start using some input values that are radians. This is good practice for us. So they're asking us to find f of theta for this particular function. We have 2 places to input that theta. So I'm asked to find f of radians. So 2 times sine of pi over 3 radians. We'll handle that in a little bit. Minus the sine of, let's talk about this part for a second, pi theta over 2 when theta is pi over 3. That's going to be equivalent to pi over 6. Okay, so there's initial setup. And I would challenge you to not just rely on your unit circle. We can't rely on the calculator here anyway. It's never a bad idea to go back and double check with your unit circle, but this is good practice for us. So if you think about pi over 6 and what that looks like, a sixth of pi. A sixth of pi is going to make a small triangle there. That's a 30-degree reference angle. That makes that a 30, 60, 90 triangle. I'm doing a horrible job with my sketch here. But if you look at the sine, which would be opposite, we're talking about the short leg here. And that is how I know that that length is 1/2. Okay, and if you're not sure on that yet, double check it with your unit circle, maybe draw a special right triangle. Now I'm going to move back to that other term, 2 times the sine of pi over 3. So think about pi over 3. If I draw that triangle, pi over 3 is equivalent to 60 degrees. This is another 30, 60, 90 triangle. But if you notice this time my sine opposite is talking about the longer leg. That's how I know that that's root 3 over 2. Root 3 over 2 is larger than 1/2. That's how I keep those two straight. Now typically I would probably simplify out these factors of 2, but I do know that I need a single fraction in the end, and we have the denominator of 2 in common here. So I'm just going to multiply straight across 2 root 3 all over 2 minus 1 over 2, common denominator, so I can put those together, 2 root 3 minus 1, all divided by 2, or some of you like to put that regular number first and the rational number second. Either of these is acceptable. So, all right, that gets us through our explanation of all of the 5-2 material, which is fabulous. And hopefully we can just keep working on practice here throughout the week. Thanks.